Okay. So my name is Anton Borisov, and I work as a principal data architect at Fresha. And today we're gonna talk about like zero downtime major upgrades at Postgres. So it's a complicated topic. So a lot of things I would cover, a lot of things I would miss. So I would leave some time for questions because it's an interesting discussion on its own, and some specific areas. So what we'd like to cover today is basically like a blueprint for doing these upgrades in general. Then we'll cover like specific complications when you do a lot of streaming and you have a lot of Debezium connectors and kind of like the complexities that are with this. Then we'll cover like different modes of switchover, because you can have like different setups like read-only, read-write, and it's actually kind of like there are trade-offs that we wish to discuss. And then about like orchestration in general. And also kind of like our specific context, why we require to do upgrades, why we decided to go this way and not the other way around, and why it was more complex than it can be in your case, of course. So let's dive in. The context. So Fresha is kind of like a booking marketplace for beauty and wellness. Just making some reservations. And it means that we run a microservice architecture. So a lot of PostgreSQL instances. I never know the exact number of databases. It's kind of like at least 100. Sometimes it's 200. Then we decommission some microservices. Then we kind of like get a new one. And because of this, it's actually kind of like very complicated, because you need to manage all this zoo park. And also we do streaming heavy kind of like setup. So we CDC data a lot. We have like an extensive usage of outbox pattern. So we use Debezium a lot. And also we had Postgres 12 and 2024. So how many of the people in the audience actually like to do Postgres upgrades? Okay, I see a couple of hands. So, but it's kind of like it's not a majority. Let's say so. The Fresha was like this. And what is the specific problem with this? Well, not that you miss performance and new features, but also because of the money. I mean, like, we are all working in some kind of a companies that make money with the software. So it means like I'm running PG12 and I'm running on AWS. And AWS has end of life kind of like notion that basically says like, if you kind of like pass the end of life notion and you are still kind of like on an unsupported version of Postgres, you will pay more just for the support, like standard support. I don't know specifically what it means, but yes, you just pay more. So it's a problem for the business. So basically, there is kind of like each year is a deadline to kind of like you need to upgrade your databases. Otherwise, you as it will be with downtime by AWS, or you will pay for extended support. Okay, we decided that yes, upgrading Postgres was so painful, so it was only done like one time. I don't know like what year. I wasn't working for Fresha, but then it was kind of like postponed until it was very late. So it was like 6 months. Next major upgrade should happen. We have like around 100 of Postgres databases, and also because of the microservice setup, we don't want to be extremely kind of like you know how to call it. I think like we don't want to get this kind of like done in a way that is kind of not zero downtime. We don't want our customers to be affected. We don't our microservices to get thrashed. We don't want to kind of like have our customers suffer from this. So so we decided to go. Let's go from Postgres 12 to Postgres 17. Just 5 major versions ahead. Bold, yes. Possible, yes. Why not? It's just kind of like something can get wrong. So if something can get wrong, what proper engineers do? They usually kind of like create a solution that is reproducible, and you can test it and account all the failure scenarios. Well, sounds like fun. So what basically do we need? It's very simple. let's define a notion of blue-green. So blue is an old PostgreSQL cluster, and green is a new cluster. They are totally in sync with each other. So all blue and green has the same data, and they are keeping in sync. So you then you need to define some point, a switchover point, where you say like all my applications before we were using like blue, now they should use green. Sounds simple. Okay, the question is really how to get this green. And then once you get like blue and green in sync, basically you need to upgrade your Postgres because you have no applications pointing to green, and it's very kind of like easy to upgrade like without any traffic going, only kind of like replication traffic, and that's it. It's all simple, and let's kind of like watch for the setup how to get like a proper green with the same data matching. And basically you define a logical replication slot. You say like, okay, let it accumulate all the val. Then you say like, okay, I want to back up my blue and save LSN. That is kind of like related to this backup. Then once my backup is done, I restore from this backup to get like a base green. Then once I get this base copy of green, I run pg upgrade, get like pg17 in our case, and then I just kind of like use this saved LSN to subscribe and advance because I have some gap. So I know that this gap is covered by this backup, but I want to jump to exact point where it's safe to start like streaming to my green instance, sorry. And then it's just a replication and consuming this replication lag gradually until I have like matching blue and green. Sounds simple. So this is kind of like a little bit more compact picture without steps, if you like this more. Yeah, so it's still the same. You have a blue one, you get a snapshot, you restore from this snapshot, you advance your replication slot to the position where you know it's safe to start like without getting any duplications and other stuff. And yeah, you get your green. So the problem, our setup, we were running on AWS RDS. How many of you actually work with AWS RDS, for example? Okay, good. So you know that they have like blue-green deployments. We tried it, but one limitation of blue-green deployments is basically you need to drop your replication slots and logical replication and basically your Debezium connectors before you even start like blue-green deployments. It's kind of like fast, but it's unpredictable downtime also because they just kind of like specify, okay, it might take like from, I don't know, like 5 seconds to 40 seconds. I mean, like it just depends on your database and what happens. It's a little bit hidden. So in our case, we needed more control. And basically, it all boiled down to that we wanted to handle it kind of like in our way, how we wish to migrate Debezium and how to handle logical replication slot, to handle all the failure scenarios. And we were not okay with kind of like offloading all of this to vendor because we were just scared. So when engineers are scared, they try to invent overcomplicated solutions. So I hope we haven't overcomplicated it as much, but there is a lot of things to cover. So Debezium in the equation. What we are talking about, like we have blue and green. We have it working, everything is fine. Now we say like, okay, I have my outbox on blue, let's create an outbox on green. Fine. Then I also kind of like show two slots because we are basically running two set of Debezium connectors. One is for CDC in data and another is for outbox. And to make the matters worse, we're actually having two different Kafka Connect clusters to run this set of connectors. And to make it even worse, we have two different versions of Kafka Connect. So some API are not supported in different versions. So we need to abstract it and kind of like create a solution that would allow us to somehow manage this. So yes, you create these slots. Then what you need to create the connectors. Use these slots somehow with accumulated changes. Then we use PgBouncer to hold client connections during switchover. And our goal is super simple. We want to have like a window when we are holding client connections and basically kind of like saying, you need to wait a little bit until we do all this kind of like orchestration. And then it's fine. And then we switch the replication direction from green to blue, just to kind of like, if we are not happy, if something goes wrong, we want to have like almost a similar setup, like symmetrical, I would say, when we can say like, okay, green somehow is not working. What to do? I don't want to kind of like panic and do some silly things. I just want to press a button and do the same switchover, but back to blue with the same safety guarantees. All good. So now it's time to talk about complicated things. So Debezium kind of like orchestration mode, as I call it. So as I said, like we have two sets of connectors. One set of connector is CDC. It's a separate cluster. The good part that we have, our sinks are kind of like idempotent and they can handle duplication. So I mean, like one of the biggest sinks is actually Snowflake, big cluster running. So we have Snowflake sink connector, and we can realize that Snowflake we CDC to a staging area, and then once we want to construct the tables that are used in Snowflake, we actually deduplicate them with some clever logic, which is a topic of its own. But that's a good part. So basically, the idea, okay, I basically can have like two connectors running at the same time. I don't care. I may so I need to just guarantee overlap of these vals, and then I just consume like old val. I may just stop this connector, and I need to guarantee some overlap to not to lose events. That's all. It's very simple, so not a lot of things to talk about. So you just can, you can do it in multiple ways. You can say like, okay, before actually kind of like migrating my Kafka connectors, Kafka Connect connectors, I'll just wait a little bit to accumulate these changes in my wall. Then I delete like old connectors, and then I fire new connectors. You just need to watch out because Debezium saves offsets. So you wish to reset offsets because if the name of the connector is the same, and you wish most probably to have it the same, because imagine that you have like Terraform and other kind of like stuff, so suddenly it becomes like an operational burden. So what we did, we used Kafka Connect API to reset offsets, and it worked like a charm. It was easy. Then let's talk about Outbox cluster, the complicated one, because there are different kind of like guarantees as well. So let's imagine that your consumers are idempotent and they support like specific ordered mode. What do I mean with ordered mode? Is basically I receive all the events in order. So it's not possible to receive event 2 before receiving event 1. It means that I literally can say like, okay, if I received event 1, I just don't care if I receive it another time. I already kind of like process this event. If you can guarantee this ordering, which was the case for us, it's kind of like also easy. So you basically have almost the same setup. You just wait for old connector to flush. And then for the new connector, you start reading from the accumulated val, and you have still the overlap, but this overlap is kind of like okay because you can handle the duplicates, and ordering is guaranteed that you process, you kind of like produce all the events before getting to the new connector that actually produces the same set of events, but the guarantee is they are not kind of like interleaving into each other. So. There are some complexities, but that is simple, like this. Then orchestrated mode. What if I don't have like a guarantee of that I handle the duplicates? Suddenly it becomes very complicated. What I wish to have is basically running an old connector and a new connector. And when I do switch over, I need to understand old connectors that, oh, okay, this is kind of like events related to this kind of like before switchover, and I allow them to pass. And this is like for the new connector is event that are kind of like for the after switchover. And after switchover, I want to filter only these events. So that way I kind of like guarantee that I only consume first like old events or only old events, and then I process new events. They can be interleaved, but because we kind of like have no duplicates, it's kind of like easy. So the question, how to do it? Yeah, it was kind of like complicated. So first we thought like about some complicated orchestration, saving in kind of like some Redis or whatever, like to just to guarantee. So it sounded super complicated. The solution was actually super simple because Debezium supports the so-called GSR223. So it means that you can use a scripting language to actually decode your message and look at some specific field. And what if this specific field is actually use PG new, for example? And PG new by default is null. So you just false. So you filter by this field and say like, okay, if this is kind of like an PG new field with default false or just false, you just allow this kind of like by the old connector. In the new connector, when you create, you say like, okay, this field is actually the default is true. So suddenly you have like a little bit not matching database schemas, but it's fine. It's not like a DML change, so replication still continues. And at the Debezium level, you literally kind of like have a guarantee, even if I have like my old and new connector running at the same time, I still can guarantee that old connector processes only old events, new connector processes only new events. And that's the whole picture. It's a little bit more info, but it's kind of like still the same idea. So blue, green, and sync. So we have like use PG17 null, use PG17 true at the top. So a different kind of like database rows inserted. And then we have all the new connector that kind of like filtering only the events that I am interested in. So what if we add replicas to this equation? Because you know, like you run a big database. You have some read-only traffic and read-write traffic, and you kind of like support it with different PgBouncer pools because it makes sense. So what you can do full switchover when you do read-only traffic switchover and read-write traffic switchover, or you can just have like a traffic switchover for read-only. And it's kind of like also makes sense because it reduces like the traffic on the database. You can literally kind of like even pre-warm your buffer cache, for example. So it makes a lot of sense. So you need to support two modes, and that's literally what we did. It's kind of like a little bit funny story because we tried to be like a good engineers. So we created like a specific function. So like this is like a read pass, this is write pass. So what is full switchover? First you do read pass, then write pass. But it actually resulted that we wait first for switchover like read only, then we wait for switchover like read write. And it was not very effective, so we actually ended up like duplicating code, like not very good engineers, but it was actually easier to test and understand. So trade-off. And then we also run PgBouncer on Kubernetes. What does it mean? We need to adapt a little bit because there is a story in at Fresha with PgBouncer. So I would tell that PgBouncer was very undesirable at Fresha because Fresha was running on Heroku first, and there were some complications with PgBouncer, so nobody liked PgBouncer. So when I said like, okay, let's do upgrades, and we need some kind of like a proxy to handle like holding client connections, there was a lot of discussions about like, oh, we are running everything on Kubernetes, so we need to run PgBouncer on Kubernetes. The problem with PgBouncer, okay, you have a working PgBouncer, you get like a client traffic, and then suddenly this pod needs to be, this node is actually closing. So you need to migrate this pod. So what does PgBouncer do with this? It just kind of like closes client connections and return errors. So you need to orchestrate it somehow. And in order to orchestrate, you need some support from application as well. So because we are running in a multi-language environment, we needed to write simplistic libraries that would actually say like, okay, you know what? I know that PgBouncer is allowed to kind of like gracefully hold, gracefully kind of like shutdown period is, for example, for 2 minutes. So it means like, okay, my application pool that has all the connection to PgBouncer, I need to disconnect and reconnect to a healthy pod that is not affected by this moving. it was rather trivial, but still required. So once we had it, PgBouncer says like, okay. Also, I forgot to mention, we are running PgBouncer 1.23, and when we were doing this kind of like upgrades, it was released only like 2-3 weeks, and it had like a nice setting. This setting is called shutdown wait for clients. So it's basically what we want. So we kind of like want to send a SIG term, and SIG term under the hood is actually using this shutdown wait for clients. And when you have shutdown wait for clients, PgBouncer is waiting for all client connections to be drained. And once it kind of like knows that no client connections are connecting to the PgBouncer, it can shut down. So it works pretty nicely with Kubernetes, and I guess it was the main reason why it was added, because a lot of companies are running on Kubernetes and nobody knows how to actually kind of like handle PgBouncer, because our SREs were very unhappy with this, and they said like, okay, this is a stateful service. We don't want a stateful service in Kubernetes, so at least we want to understand how to run them. So it was a story of its own. And then PgBouncer reload problem, because as I said, like, okay, you have like a PgBouncer as a proxy holding your client connections, and then suppose we had our config as config maps, then we updated these configs, and then there is like live reload, but still you need to for these configs to propagate. So you're holding your client connections, and then you're waiting for this config to propagate. It's kind of like can take some time. For example, sometimes it takes like for 1 minute. So what we ended up, we delivered like a specific configs for kind of like read-write switchover, like new host. Read-only switchover, new host. So we just kind of like connected the different configs just to guarantee that we would have these configs available once we do switchover. Sounds complicated. It is a little bit, but it was the only way to make it work like reliably without like relying on propagating config maps and whatever. Like so, yes. An interesting part about it is I was the one who created the initial script to do this switchover, and the idea was to run it first like on localhost on Docker to demonstrate that it can work. And I decided to write it in Bash. Because it was a challenge of its own. I just thought like, okay, I use Bash for kind of like simplistic scripting. Can I make like a very complicated Bash script with the support of somehow moduling and other stuff? And yes, it turns out it's even possible with Bash. I was a little bit surprised. No, I wasn't surprised, but it was a new learning for me as well. So I structured like separate models for Debezium, error handling, health checks before doing switchovers, like logging, PgBouncer part, because as I said, like we are running on Kubernetes, so we need to add an additional like wiring to make it work. Because for example, if I send polls to PgBouncer, then it means I want to send these polls to all the pods on my cases, and I wish to send them asynchronously and not synchronously one after another. So it required some specific handling as well. Then sequences, replication, so it's just like a good modeled code. How to run it? So that's basically how it works. So you get like run sh, switch over, and then direction. So direction, what does it mean direction? You have a forward and backward. So as I said, like first we want to migrate forward. If something goes wrong, I want to run the same command, but just change direction to backward. And then it would actually do the same, but in back to the blue cluster. Then mode, full or read-only. I mean, like maybe I first want to test like if my if I migrate my read-only pool, would something break or not? Because read-only is easy to handle, so it's just read-only. So if something goes wrong, I just kind of like need to point to a different host, and I wouldn't have any data corruptions and any problems. So then Debezium mode, that's the thing that we discussed. So it's kind of like handling CDC, outbox, kind of like maybe this orchestration mode. So here it's actually orchestration mode, yep. And then transaction mode wait. It's a trade-off setting, because for example, imagine that you are doing like a switchover and you have some transactions still running in your database. You have two options. You can terminate them, and it's totally fine, because if you receive like 5-7 errors and your applications are fine to handle them, then it's good. Or maybe you kind of like say like, you know what, I actually care to have like a really 0 errors. And then you need to guarantee that your connections, that your queries are terminated. So you have like a proper timeout, because you don't want to say like, okay, I may wait for this query for 30 minutes to finish, and all this time like I accumulate client connections, and because you know what would happen, it would be kind of like a connection storm, yeah, not very nice. So this is like a trade-off setting. You need to kind of like play with it and understand like, can you have like a timeout? If you don't have like a timeout, can you introduce it? What is kind of like the impact if you kind of like fail, for example, like 2% of the queries that are currently, when you execute like a switchover, are running in your database? How much do you wish to wait until you say like, okay, we don't have a timeout, but 95% of my queries, I actually would finish it like in 3-5 seconds, so maybe fine. Yes, you just specify, so this is like a trade-off setting. Then test catch-up. Another kind of like safety nets setting, because imagine like I'm an engineer, I'm about to run a database upgrade, and I don't know how much it would take, because like databases are different. I'm not sure how fast these sequences will be created, how fast I migrate like Debezium and other stuff. So I need to have some kind of like a baseline to understand like how much it would take. So test catch-up is basically running all this stuff until the actual switchover of the in the PgBouncer, like a proxy. The idea is basically, if something goes wrong, you still kind of like not writing into the new database, so you wouldn't have your data corrupted or whatever, duplicated, but you still can have like say like, oh, mini incident. So it actually took like, for example, 15 seconds, and I wanted to take it like 5 seconds. So maybe I need to speak with the team and say like, can we terminate the queries for 5 seconds and introduce timeout for 5 seconds or not? Yep. So this is about this. And then the last one is config switchover, because the idea was to actually have like a single config with all these settings specified per blocks. And then for engineers and SREs, it will be easy to reason what is actually kind of like running, because as I said, like there are a lot of decisions. You don't wish them to scatter around the code, around the bash. So you just YAML, and this YAML provides you a picture, what do you want to achieve, and it's easy to review, because even for me, when something goes wrong, like our guys call me and say like, oh, something is not working. So first action for me is go and study this YAML. And that's it. Now I know what they're doing, at least, and I ask the questions kind of like, why are you kind of like waiting for transactions for 30 seconds? Something like this. It happened. So let's go a little bit kind of like for this setup. So we have sources and targets settings. We specify like replicas. So if you need to do like read-only switchover, you need to specify like replicas. Then you have database level settings. So basically a name, user, password, names of the logical replication slots, subscriptions, transaction wait time. So then you have PgBouncer. So you need to specify for the PgBouncer where this config for doing this kind of switchover is, what is the name. So then you have Kafka connector, connector settings. So if you have multiple clusters, you need to specify them. I mean, like you can rely on auto discovery, and we have a version of this script doing auto discovery, but our engineers felt unsafe, and they said like it's better to kind of like specify our assumptions like in a direct way, so we can be sure that everything is kind of like good. And then we have like Debezium and other settings, as I said, like because replication, duplication mode, lag, because sometimes you don't want to start like this switchover and basically make your blue cluster as read-only before you are sure that the replication lag that you accumulated in your slots and kind of like in your physical replication from blue to green, logical replication, sorry, from blue to green to be big. So basically what the script does, you push the button and it waits until the lag is at the acceptable level to guarantee that once I'm in the mode when I need to do all this switchover as quick as I can, I have like the least amount of work to catch up. So this is also configurable, and others kind of like settings just for safety net, but it's basically the whole config. So it can fit on a single kind of like listing of your laptop. Easy to reason. I think like it's good. The core logic. So it's bash. I don't know, like it's quite dense in some point. The important part is watch out for these sync sequences. So for a large databases, when you have like thousands of tables, kind of like syncing the sequences can take a lot of time. So the first version of this script was actually doing, because it was tested on local environment with a Docker. I literally didn't care when these kind of like syncing the sequences would be situated. Once it got to production, we needed to factor out these sync sequences because it would take time. So before kind of like entering like read-only mode on a blue, you wish to sync sequences outside of it. Then you specify, you wait for logical replica sync. So it's related to the settings that I demonstrated. So I thought like, okay, how much lag are we okay between blue and green to actually start like switch over. Then there is a Debezium handling mode, creating a connectors in handle connector switch, and then we switch replication direction, update PgBouncer pool, which exactly like a resume, and if kind of like local mode, so it's kind of like related to PgBouncer, so you can skip it. Then we just, oh, we also have a to-do. I mean, like maybe in a section that is called like what is the future for this stuff, I need to add like fix all the to-dos that we have, because it's almost like 1 year or more, and I still have this to do in the source code, because I was preparing this slide, I guess, 5 days ago. Yeah, and it's still to do here. Crazy. Okay, let's talk about sequences. What is the problem with sequences? You do logical replication, so you replicate your data, but the problem is on blue cluster, your next val would point to some big number, and on your green, your next val would point to a 1. So you need to use setVal to specify like a proper number that is consistent with sequences on blue. So just to kind of like guarantee that you wouldn't have like your data duplicated, because you would run like an insert statement, and this insert statement would use like a value that is given by next val, and it would be kind of like, okay, I cannot insert this row because I already have like this primary key. So that would that can happen. So you need to be extra careful about this. Okay, the next problem. You kind of like have this PG-17 upgraded, all good. And then you try to use it, and suddenly it's too slow. Does anybody know what's the problem specifically to AWS RDS, by the way? Okay, so it's slow because EBS loading, because Postgres and RDS specifically decided to be lazy. So I restored from a snapshot, but I don't have data available. So I need to go and fetch it from EBS once it's requested. So it means like if I accumulated a lot of client connections, kind of like I've been held in them for a while, and then I say like, okay, your kind of like green instance is available, fetch the data. And then suddenly I request the data, and this data is not available. I need to actually go to and load it from EBS. Not working. So what you can do, you can pay for AWS, and there is a feature that's called like fast EBS loading or something like so. I might be confusing the name, but yeah, the idea is you pay money, you get like your data prepared. Or you can do pre-warming. So you just we created a specific script that actually fetches all the tables and just runs some queries, just to guarantee that first we have our data available, not on some kind of like EBS, relying on some EBS loading. And also this data is in a buffer cache to guarantee that once we do a switchover, our queries wouldn't have hard time to actually kind of like process these queries quickly, because otherwise we would still accumulate a lot of queries and there would be problems, of course. Another problem, analyzing green. So I run the query and suddenly the plan is different on green. What went wrong? Yeah, of course, it's kind of like analyzing, because as I said, like what you do, you restore from snapshot, you get a green green cluster, and you need to upgrade this green cluster to the desired major version. And once you get it, like during upgrades, statistics is not like transferred. So before you had like a normal distributions, and on kind of like your green, now you have paranormal distribution, and your queries can behave funny and different. So you need to watch out for this. It's It's easy to miss because that's literally what we did when we did first upgrade, and we got like a very kind of like not nice feedback from a team whose databases we decided to get as a reference. So we fixed it. Now we run analyze. But yes, all these things should be kind of like orchestrated. You need to remember, you need to watch out, you need to kind of like prepare if something goes wrong. So all the proper engineering practices here are also applicable. Okay, is it really a zero downtime? Yes. In theory, all of these kind of like guarantees a zero downtime. But we are living in a real world, and you need to kind of like watch out for the trade-offs. And trade-offs are super simple. So you have a lot of client connections connected to PgBouncer. Some of these client connections kind of like, you can accumulate them a lot. So what do you wish? To wait until these connections would actually time out if something on application level is configured like for, I don't know, like timeout 3 seconds and switchover is taken like 5 seconds, for example. So you either need to fix your application timeout or you kind of like, you would get these connections dropped. Then another trade-off is basically, okay, I'm waiting for the transactions to finish until I run the actual switchover with the PgBouncer, kind of like replacing host and whatever. Like, should I wait for 10 seconds? Yes, that's another trade-off. So, and also there is a complication very specific to Fresha because Fresha is running Elixir. Do anyone from the audience have an experience with Elixir? Okay, not popular. Yeah, I guess. But Elixir is a good language, and especially what's good, it's a library, ORM, basically Acto. This library kind of like hides all the complexities. It's very similar to Active Record, and it's also very different because there are some additional features specific to Elixir. The one feature that is specific is kind of like handling back pressure. So, for example, I have an application pool. This application pool kind of like have, for example, 10 connections, and they map for, I don't know, like 3 PgBouncer connections, for example. All good, but suddenly kind of like your PgBouncer is in the switchover phase, and you accumulate your queue of incoming requests, not an application pool, but a queue of incoming requests. So Elixir, what it does, just to kind of like not to lead to out of memory errors, it has a queue back pressure. So this queue back pressure, it means like if an average size of the queue is bigger than this and kind of like it takes longer than usual to process and it's kind of like configurable, then this request would be dropped. So you receive DB connections errors in your application. Is it good? Well, usually kind of like applications know about this back pressure, so they are designed to handle this gracefully, but sometimes it's still kind of like a bunch of errors in your Datadog alerts, and it's annoying for people, they get scared, and yes, so basically another trade-off, you either need to change this setting to a sensible value in all your microservices. And imagine if you have like a gigantic database that is having like 200 microservices, and you need to kind of like reason about these settings in every single microservice. Suddenly it becomes like, well, maybe I don't want like that zero downtime. So basically what we do, we just increase like application pool size a lot. So we can kind of like have a headroom to handle more more web request, for example. I will call it web request because basically, yes, web application. And it's easier to distinguish because I'm talking like a queue and pool. So pool is an application pool. So it's just like a connections to PgBouncer holding. And queue is kind of like an incoming application request. So they're a little bit different, though related. So if I have a small application pool, I have a long queue of incoming requests that would be dropped by Elixir back pressure mechanism. So it was specific to Fresha. In Ruby applications, we didn't have it. So what it resulted when we switched over Ruby applications, it was easy, so nothing failed. When we switched Elixir applications, there would be a spike of DB connection errors that actually kind of like were caused by Elixir back pressure mechanism. So for a lot of applications, we just kind of like muted the Datadog alerts because applications were okay to handle them gracefully. Elixir is very kind of a concurrent language, so it was easy. Troubleshooting. What if something goes wrong? I mean, like a lot of things can go wrong. So you do a switchover. So you have like your Debezium connectors, and somehow your Debezium connectors are not moving. Yeah, it can happen. So what guarantee you have? Because you have your replication slot, and this replication slot has all the data that you need for your connectors. You just need to figure out offsets and whatever, like you have the data, you can start from it. If you kind of like handled your Debezium mode, you have a guarantee from this Debezium mode. So sometimes you can, you are okay to duplicate, so sometimes you need to orchestrate, sometimes you can even kind of like have to deploy a new version of Debezium connector when you use some kind of like a filter, like worst case scenario, but the data is still here. Kind of like you just need to watch out because as we know in Postgres there is a setting when you actually drop like val or you accumulate a lot of val until it eats up all the disk space. So yes, it's kind of like safe. It's just kind of like you're buying some time to figure out what went wrong with your Debezium connectors. And also, as I said, like there is like a forward backward switchover like mechanism. So if something goes wrong, you just kind of like, I have no time to figure it out. My users are waiting for my applications to work. So I just kind of like get back. That's it. Then we study the logs and it should be fixable. Then the last bit is cleanup. So once we got like this backward replication at place, what we need to do, we need to check the dashboards, monitors, kind of like, I don't know, even ask users, are you noticing something like funny with your applications, with using like Fresha or not? Once we have it, we can tear down like backward replication. We can delete like blue instance. We can, I don't know, like delete DMS subscription. I call it DMS because yes, we all know that AWS has DMS, so I kind of like created this name as kind of like a matching name, but people sometimes get confused and they say like why I have decided to use this name, but whatever. So cleanup is easy. You just need to check your dashboards. Sometimes we, for most important databases, we keep replication going for an additional 1-2 days. And it has downsides because it's a logical replication. So if you do schema changes like DML, then your applications would actually break. So in order to kind of like not to have it, what you need to do, you need to disable your migrations during switchover period, and when you kind of like restore from a snapshot, you consume replication lag and whatever. So it means that your developers are not kind of like are not able to run migrations. So this is also a trade-off. So for the biggest database, we were actually running for 3 days just to check out if everything is fine, and then we kind of like kill the old instance, and our developers were not super happy, but yeah. So recap. All in all, like I hope that the whole picture, at least kind of like of steps and things to watch out, are at your at place right now. So let's quickly recap what we did. So we needed to have like a blue and green instance. You need to upgrade green instance. Then you need to pre-warm and analyze. Then create replication slots in green. Move sequences. Then you stop the writes. Allow transactions to finish. Pause PGB pool. Change host in PGB pool. If it's like read-only, you do you only change kind of like host for read-only. If it's like read-write, you change 2 hosts. Then you do Debezium connector orchestrations. So by orchestration, I mean like you need to create like a new Debezium connectors, kind of like watch out for the names and do all the other stuff. Then once you have like a your green and blue in sync, then you allow writes to green, you reverse replication direction, and that's it. You just kind of like work done, then only cleanup remains. So if you prefer to have this kind of like slide because it's a lot bigger, but it looks more serious, so you can also kind of like watch out for the whole picture. So I created like in blocks. Maybe it should be in bullet points, you know. But that's the process that we came for, which works, and it's easy to document. Okay, production. As I said, there is a kind of like a complexity because we're running a PgBouncer on Kubernetes, and the script was kind of like a simple bash script. So we needed to deploy on Kubernetes, handle all the Kubernetes kind of like configs and other stuff. So I touched this subject a bit when I talked about like config reloads and config maps propagation, but also it's kind of like a little bit more complicated story, and it's not that very interesting one, in my opinion. It's just kind of like you need to handle a lot of like configs, you need to create a lot of PRs, you need to wire it up with your CI/CD. So why it's complicated? Because of the automation. I mean, like the idea is basically we have like a small SRE team, and when teams do database upgrades, it's usually kind of like they're waiting till deadline, and then SRE teams are overloaded. They need to upgrade like 100 of databases kind of like to meet the deadline. And because of this kind of complexity running on Kubernetes and then kind of like AWS, you need to kind of like also talk to AWS API. And there is kind of like some permissions, roles, and other stuff. So it means that still, even with this script, you need to rely on your SREs. And the way to kind of like automate it is kind of like you go to your SRE and they tell you, okay, you know what? You need to open 12 PRs. You need to first connect to like PgBouncer. You need to declare like new configs for PgBouncer. Then you need to like to add templates for Helms and other kind of like stuff. And developers, developers, they just say like, yeah, it can wait. I mean, like we have a very important feature to develop. So kind of like database upgrades is good, but it's not so super critical. So we want to do better. So we actually kind of like started like half a year project to automate it. So the idea is basically to have Lambda step functions to basically provide a restricted access to the parts that are needed for the specific steps of the script, and then they will be executed and communicated and synchronized between each other and kind of like observable. It improved a situation. It's still kind of like in progress because yeah, it's just taken so much time, so that our SREs are actually kind of like moved to another project. But still, this is kind of like the idea. That's the team behind this. We needed a lot of people. Some of the people, for example, Blend, he was preparing this snapshot restoration on AWS, so specific area responsible. Then we had Paritosh, who actually helped because we don't have so much SREs, so we need to put him from another project so he can run this script. And it was very stressful for him because he thought like, okay, this is kind of like some raw script. I have some guarantees, but still I kind of like don't feel safe. Then we have Robert, our Kubernetes guy, who actually kind of like was very, I'm so afraid to run this on Kubernetes and other stuff, so a lot of things can go wrong. And then Pavel, Jan, who actually helped like with delivering PgBouncer on Kubernetes, and Emiliana as a head of infrastructure and data engineering, who actually allowed it. That's the most important part. And yeah, conclusions. Upgrades are nothing more than orchestration. We upgrade every major version now every year. It's a routine, so we don't wait another 5-7 years. And knowing backup, replication, and Postgres in general just pays off because you can do interesting stuff. And yeah, it was cool project. I mean, like I enjoyed it a lot. And yeah, thank you for listening. So if you enjoy the stories like this, we usually post it in Fresha data engineering blog. So I write about like Postgres, streaming, OLAP databases, Flink, Flues, other stuff. So a lot of stuff to cover. So if you enjoy this nerdy stuff, welcome. And that's it. Time for questions. No questions. I'm surprised.
What kind of tests have you done before actually doing the switchover regarding the data consistency and corruptions related?
That's a good question. So basically, what we did, like we had a set of tests to kind of like guarantee that kind of like the most important queries, they just work. So we upgraded with this switchover like to a green instance, and then we kind of like have an integration test. So we run against this. So we also kind of like checked like if the data was replicated fully, and it's actually paid out because we messed with something during like restoration with the snapshot. So we needed it. So yeah, just a normal test when you kind of like replicate your data. Nothing too specific. We had some tests related to Debezium connectors because, as I said, like sometimes they would, depending on the version of Debezium, sometimes even if you kind of like reset offsets, they wouldn't restart because there is kind of like a switch in Debezium that tells like, okay, I don't know this kind of like LSNs that I track, they seem before that I actually saved, so it just refused to work. So we needed to kind of like do an additional kind of like steps. We upgraded to the Debezium version that handled this kind of like correctly, and it was the recent version of Debezium. And it was also discovered like when we have like a monitoring on Datadog. So we literally connected Datadog, and when we were running integration test, it kind of like simulated our production environment. Any more? Okay. So if you have any more questions, I'm happy to answer them, because as I said, like there are a lot of more interesting stuff to cover, starting from PgBouncer to Kubernetes, if anyone likes Kubernetes. I personally don't. Okay, thank you. Yeah, almost forgot. Huh? Yeah.